Hey, aloha, everybody. Welcome to Module 2. This is the one where we really dig into the cognitive neuroscience and related to our model to learn. Along the way, I hope you enjoyed the hopefully inspirational video of being a Mr. Jensen, and then also the active learning, and that's kind of gotten you thinking about the neuroscience of active learning. This module, in a lot of different ways, is going to through multiple videos and some research briefs, a research brief for you to read, is really the module where we cement all of the neuroscience. From here, we'll do 3 learning walk modules and then 3 habit mapping. So you may want to come back to this module a couple of times. I hope it has great information for you. It's really the why behind all of it, and I hope you get a lot out of this module. So let's get started. So there are 4 habits of powerful teaching learning related to the cognitive neuroscience research. Um, the brain wants to feel safe. It would like to be interested in what it's learning and it would like to talk about it. This module is really about pictures. It can be that simple. There's your big organizer. Be thinking that's the gist behind it. The brain loves pictures. So let's dive into put some more details around that. Now you've got the whole rubric, 4 habits. We know we started at the bottom when we're working our way up. And again, this is really the pinnacle. This is what we want when we're talking about kids learning. We want kids to learn, and we want to learn for ourselves. We want to not only know things but really understand them, and that's what model to learn is all about. Model to learn does not mean that the teacher's modeling it for the kids. Is that the kids get their hands on a model, that they touch it and feel it and that kind of thing. And we're still in the area of Bloom's taxonomy. So we know we're going with higher level learning, application learning, synthesizing information, all of those kinds of things. In talk to learn, we have kids talking about it so they know it, but now we're moving it into the model to learn so they can try to understand it. And you're going to see the importance of student-centered learning for sure as we move forward here. All right. The key terminology that we're going to be zeroing in on here is symbolic reasoning. I hope you've enjoyed. We've seen lots of schools really organizing around this, and when we do jam boards and reflect on what we've learned so far, lots of teachers using language like emotional regulation, selective attention, elaborative rehearsal. Well, we really hope this idea of symbolic reasoning gives you a tag to hang your learning on to keep bringing you and your colleagues back to. That's really what we're trying to get at. These higher levels of learning is really this idea of symbolic reasoning and understanding. So, and the way we get at that are habits. When we might find that we have habits related to recalling information, or we might have habits of truly developing conceptual understanding. So, the reason we have the rubric on all 4 of these habits is so we can find out which columns are we in as we think about all 4 of these. So today, in this course, we're going to be really looking at the difference between just recalling information and really building conceptual understanding. And we're really focusing on the conceptual understanding part. All right, so our learning target for this module, uh, we're continuing to learn about the 4 habits of powerful teaching and learning. Related to model to learn, there's 3 bullets, and these 3 words have something to do with the 3 bullets that are in that third column on that rubric. I hope you've read through the rubric a little bit and you're getting to know it. In the third column of model to learn, there's 3 bullets there. The first one has to do with organizing information in some way. So I want you to be thinking about how do you have your students organize information? 2, how do you have them process their information? And 3, what role do visuals play for you in your learning? In this module, it's jam-packed with lots of neuroscience research. And so hopefully this will really build a foundation for you and you'll see the importance of why we want to focus on multisensory learning. All right, so as we roll this out, we're going to be sharing just a little bit about the neuroscience behind the research. I'm going to connect it to the 4 habits rubric, and then your assignments throughout this are really to connect it to your own instructional habits. What did you learn? Be thinking about what did you learn from this presentation, and then also how can you apply it to your classroom? All right. For those of you that have taken all the classes, you know that Ready to Learn, our tagline was stressed brains do not learn very well. And for What to Learn, the brain does not pay attention to boring things. And for Talk to Learn, we said if students, if they don't say it, they probably didn't save it. Well, here's our tagline for Model to Learn. Vision trumps all other senses. If they didn't see it, they probably didn't understand it. And so we're going to be talking about multisensory learning. We're going to talk about the importance of all of it for connecting the brain and learning information. But in the end, we're going to be really narrowing it down to, uh, uh, at the very lowest denominator, really vision trumps all of these senses. And so we want you to make sure you're focusing on that as well. So ready to learn and what to learn had to do with Maslow's hierarchy of needs and really amygdala management. But talk to learn and model learn, they continue to work together. They're both about Bloom's taxonomy and they're both about hippocampus management. We're now moving information through the hippocampus and into short-term and long-term memory. We're also trying to add a third kind of memory called sensory memory. And so we're trying to get using all of our senses to help create memory along the way. And we do that by means of symbolic reasoning and trying to develop conceptual understanding rather than just giving information to students and them giving that information back to us. It's a very hard way to, to store and retrieve information. But the more conceptual we can make it, the more hands-on, active, multisensory, the better it is for the brain to store and retrieve information. All right, so the neuroscience portion. Now, we talked about symbolic reasoning. The brain actually reasons symbolically. It understands things in symbols. It understands things in pictures. So if we want to find out, if we want to help the brain understand things at a conceptual level, we need to use pictures. We need to use symbols and those kinds of things. And these are all around us in our society with emojis and signs and those kinds of things. But the brain, even when we're reading words, one of the very difficult thing for the brain to do is to read. And the reason that is difficult is because the brain interprets every letter as a picture, and then it has to put it all together. So the brain, the first thing is the brain reasons symbolically. If we want kids to learn something and know something and understand something, are we using symbols, pictures of things that they can use? If we only use words, it's one of the hardest ways for the brain actually to be recording information, is just linguistically or just reading words. So at the heart of it, model to learn, knowing something and understanding something are two different things. That's at the heart of this. That under talk to learn, we learn some things and we talk about it and we explain our reasoning. But to truly understand something usually takes a picture. It takes a model. And sometimes maybe you've heard people talk about CPA, concrete picture and then the abstract. Well, that's what this is all about. Is start with something very concrete, then move to pictures, and then you can move to the abstract. We've seen this in classrooms all across Hawaii, and it's really fun to see. But think about all the different things that maybe but when it really comes down to it, I don't know if I really understand why that is. For me, one of the first ones was, dividing fractions. 1/2 divided by 1/4. Why is it that you invert and multiply the second fraction? Why can you not invert the first fraction? To divide fractions, why do you multiply? I know what to do, but it wasn't until I was in a fifth grade classroom over in Hilo, and I was watching the kids have to explore and draw pictures of 1/4 divided or 1/2 divided by 1/4, and they had to draw pictures of what it meant and work together in groups and try to come up with a mathematical rule algorithm that would help them solve these in the future. It was fantastic, and I understood it for the first time. So that's what we're really looking at: is we can know some things, but do we really understand them? So as we do this, you'll notice in the rubric, kind of front loading the rubric just a little bit, but think about this. Once we give students information, what do we have them do with it? And we're just suggesting, rather than students giving information directly back to us, like I give you a list of dates, people, places, that kind of thing for social studies or math algorithms or things in English from a story, ELA from a story, or any topic, any subject area. That when we give information to students, that we have them do something with it. We have them organize it. We have them categorize it. We have them compare and contrast. But rather than just trying to give information, memorize it, and give it back, that's one of the hardest things for the brain to do. So, to what extent do we have the brain do something with it? And we know a lot of these things. We know a lot about habit maps and thinking map, or not habit maps, thinking maps and graphic organizers and some of those kinds of things. of taking a big idea and then taking the evidence and pieces from that. Uh, so I want you to be thinking about how do we have students organize information in some way? Maybe you use some of these graphic organizers. Maybe you have uh, some thinking maps that are really favorites of yours. One of the ones that's not in here that I don't see right now is like a Venn diagram. What are the similarities? What are the differences? And how can we have kids solve those things together? So the very first step is when I give students information, do I have them do something with it? Preferably visual and with their peers, as you'll see. But do I have to do something with it before they give it back to me? All right. So in that thing that we want them to do with it, we want that to the way they process their information. Remember, I said we were going to talk about how we have students organize information and then how we have them process it. We're going to encourage that the way we process it is that students would be engaged in a multi-sensory encoding, that they would be using all of their senses to encode initial information. Don't start with bits of information and hope to get to that sometime down the road. The best way for the brain to learn is the initial learning of a topic, that it would be multisensory right off the bat. And just like with talk to learn, we said elaborative rehearsal was so important, where kids would talk and explain their reasoning. Well, elaborative exposure is the key to model to learn. So as we're going through model to learn, it's can we get kids to have all of their senses experience the learning, their sight, their hearing, the sound, smell and touch. Just be thinking about not just labs and things like that, but just every day. How can we help kids get hands-on? Again, CPA, concrete, hands-on, a model. They can touch it, they can smell it, they can see it, they can hear. They're encoding on all of their senses, not just hearing and taking notes. Think about hands-on, up and moving around, kinesthetic, active learning, where kids are there's movement connected. As you'll see through a lot of the videos we show you in this course, it's intentional movement connected to the learning. And when we do that, the brain encodes that information in multiple ways so we can get that information back. Not just giving information, trying to memorize it and give it back to the teacher. It's here's some information. Now go use it, play with it, experiment with it, move with it. It's multi-sensory, and that causes the brain to be able to record that information in multiple places and thus retrieve it in multiple places. And also, what's really important with this is, and you'll see this in just a minute in the bullet number two, is and they do all that moving and around and multiple sensory exposure with their peers. So now there's a difference between getting a Venn diagram and filling it out as a class, one person at a time raising their hand, and the teacher filling it out and kids copying it. That's very different than the kids just having a Venn diagram in front of them and saying, okay, what do we do with this? And them working their way through it. And so we're really encouraging this idea of multisensory exploration because of how it allows the brain to encode that information. So be thinking about all the ways like I mentioned earlier in the course, we already know about all these things. What are some ways we've been doing that online? What are some ways you've been able to figure that out? Whether it's using Padlet or um, uh, I know some people are using virtual reality software and some other cool stuff. So how have you been doing it? Be thinking about your own practices along the way. But the key is hands-on. Kids' brains are interested in hands-on multisensory learning. But in the end, and you're going to see this reflected in the rubric, okay, get information, do something with it. Do that something with your peers and make it multisensory. But in the end, vision trumps all other senses. About half of your brain's energy is taken up by your visual processing. And so this idea of symbolic reasoning, pictures, if that's a starting point for you, just think about how can I use pictures in my class for students to be looking at. So, and you're going to be hearing in this. I don't want to give away all the research on this. There's multiple things in Module 2 where you're going to be able to learn a little bit about the research and the power of pictures and words together at the same time. All right. So In summary, we're heading towards a summary here and headed towards the rubric itself. In Talk to Learn, we said we need to say it, get the kids to talk, have them say it to save it. Now what we're suggesting is we've got to see it to understand it. So as we start to think about the rubric, we start to think about our own habits, just be thinking about how often do I allow kids to see and explore the information rather than just write it down and repeat it back. All right. So we're trying to build conceptual understanding. You can see that it's not just recall. It's not just filling out a Venn diagram or a T-chart as a whole class while I copy information in. It's truly exploring with my peers. Okay. So, and we're focusing in on that symbolic reasoning. We mentioned that we're always focusing in the third column. When you do your learning walks, and if you do a learning walk with all four of these, you start in the third column. In this course, you're going to be doing the third column of just model to learn. For our focus, I mentioned to you that I want to talk about the research and now the rubric a little bit. It's the third column. There's a lot of words in there. There's 3 bullets I've been referring to. But here they are blown up. I just want to read through them with you. The first one is teacher provides students the opportunity to develop conceptual understanding. So this is really about the teacher. I'm going to give you an opportunity to develop by conceptual understanding by having them use existing information. We've already gone over all this information. Now let's do something with it. Let's organize it. Let's sort it. Let's develop a sequence. I've seen some really cool things, like even in a kindergarten class with numbers 1 through 10, where kids sequence information together and explain their reasoning. It's so great. They create a visual from it. And 2, the second bullet, students communicate their understanding or application of knowledge, their information to their peers. Okay, through multisensory hands-on activities, learning activities. They're moving around. It could be that they're just moving from station to station in the classroom, or they have a model on their desk, or they have a Venn diagram they're trying to fill out together. But they're working together with peers with visuals and hands-on activities. Third one is that we are having students create or use a model. That's why it's called model to learn. They create or use a model. They use some sort of a visual or graphic organizer, or don't have to do all these things, or a non-linguistic representation of information, aka a picture. So as you go through this whole course, you're going to be doing learning walks looking for these 3 things. Do I see the teacher having the kids organize information? Do we see them having multisensory experience with peers? Is there actually a visual connected? And when we actually do this the way the brain really likes it, all these things actually happen at the same time. All it is the kids up moving around a little bit with each other with a visual that they're trying to solve together. So we have it broken down into 3 different bullets, but they can all be actually one activity. You'll be doing learning walks looking for these things, and then you'll also be planning them into your own activities. And this is a handout in the summary in this that I think is really great to just have on hand when we think about what this whole idea of all of the parts of model to learn. It's about conceptual understanding, using existing information, organized sort sequence, trying to form deeper meaning. It's about again supporting that student learning community of multisensory learning, communicating our understanding, discussion of our application of our learning, and then really understanding things through visuals that we actually have a model. We model conceptual understanding. We use visuals or graphic organizers, and at the very least, we just use a picture. We could have kids draw a picture before they write an essay, things like that. All right. Well, I know that was a lot, and that was a long time. You hung in there really well. The goal of this module is to begin to introduce really the heart of it, what multisensory learning is all about, to give you the neuroscience behind it, and to get you thinking about how do you have your kids organize information after you give it to them? How do you have them process it in a way that is multisensory? And in the end, at the very least, what kinds of ways are we using visuals, whether it's a model or a graphic organizer or actually just a picture? So I hope this is a good start for you. There's a lot more in this module. There's a research brief and a couple other videos and lots of places for you to reflect. I hope you take advantage of those opportunities. The more reflection you do along the way, and then when you get done with the module in the end, it's going to be a great entry into your portfolio. So, hey, wish you well. Thank you for being a part of the class, and we hope that you enjoy it. Enjoy the rest of the module. We'll see you out there online.